October 1943, North Africa. Oberst Hans-Joachim von Ravenstein stood in the commander's cupola of his Panzer IV, watching the horizon shimmer in the afternoon heat. The veteran of Poland, France, and now the desert campaigns had seen much in this war, but what appeared through his field glasses that day made him laugh out loud. Endless columns of American tanks stretched across the sand like toys from a factory assembly line. Shermans. Hundreds of them. Maybe thousands. His radio crackled with similar reports from other units. American tanks everywhere. Too many to count. Von Ravenstein transmitted to his battalion commanders with undisguised amusement. The Americans have sent us their tractors. Count them if you can. There must be a farm somewhere missing its equipment. The German officers shared his confidence. They had studied American armour. They knew the Sherman's weaknesses. Thin armour, inadequate gun, crude engineering. The Americans had simply built thousands of inferior machines thinking quantity could replace quality. It was a mistake the Germans would punish severely. What von Ravenstein and his fellow officers didn't understand that October Day was that they were witnessing something unprecedented in military history. Not just tanks, but the complete transformation of warfare through industrial capacity. The Americans hadn't sent tractors. They had sent an avalanche of steel that would bury the Wehrmacht under its weight. This is the story of how German tank superiority became irrelevant, how American factories did what German soldiers couldn't, and how the Sherman tank, dismissed as inferior by experts on both sides, became the weapon that crushed the Panzer arm through sheer overwhelming numbers, backed by tactical flexibility and logistical genius. In 1940, American tank production barely existed. The entire United States Army possessed fewer than 400 tanks, most of them obsolete light tanks with riveted armour and machine guns. When France fell in June 1940, America suddenly realised it was completely unprepared for modern armoured warfare. The German panzer divisions had demonstrated a new form of warfare, combined arms attacks with massed armour, breaking through defensive lines, followed by rapid exploitation deep into enemy territory. The Blitzkrieg had conquered Poland in weeks, France in 6 weeks. The age of the tank had arrived, and America was hopelessly behind. President Franklin Roosevelt, watching Europe collapse, made a decision that German planners would later identify as the beginning of their defeat. In May 1940, he called for the production of 50,000 aircraft. The announcement was met with skepticism from military experts worldwide. America, which had built fewer than 6,000 aircraft the previous year, would suddenly produce 50,000. What the skeptics missed was that Roosevelt understood something fundamental. American industrial capacity wasn't limited by current production. It was limited only by commitment and organization. Once that industrial machine focused on a goal, nothing could stop it. The tank program began in chaos. The US Army Ordnance Department had conflicting requirements. Infantry wanted heavily armoured breakthrough tanks. Cavalry wanted fast pursuit tanks. Armour advocates wanted medium tanks capable of both roles. Various prototypes were tested, rejected, modified and retested. Then, in August 1940, engineers at the Rock Island Arsenal in Illinois combined features from several prototypes into a single design. The medium tank M3. It was an awkward machine with its main 75mm gun mounted in a sponson on the right side of the hull, requiring the entire tank to turn to aim. The British, who would receive thousands under Lend-Lease, called it the General Grant and General Lee depending on the variant. Despite its flaws, the M3 was in production by April 1941, 8 months from drawing board to assembly line. The Germans, by contrast, took years to develop and field new tank designs. The speed of American development should have warned German intelligence that something unprecedented was happening. By December 1941, when America entered the war, multiple factories were already producing M3 tanks. But American engineers knew the M3 was a stopgap. They were already working on its replacement, a design that would become the most produced tank in American history. The medium tank M4, which the British named the Sherman, after Civil War General William Tecumseh Sherman, emerged from lessons learned in North Africa and the Eastern Front. American observers had noted that German tanks were technically superior, but operationally fragile. They broke down frequently. They required extensive maintenance. They couldn't be quickly repaired in the field. The Sherman was designed with a different philosophy. mechanical reliability over technical sophistication, ease of production over engineering perfection, repairability over optimal performance. Every design decision prioritized getting tanks to the battlefield and keeping them there. The result was a tank that German engineers considered crude. The armour was simple rolled steel plate, welded or riveted depending on the factory. The hull was tall and angular, presenting a large target. The 75mm gun was adequate but not exceptional. The gasoline engine was less powerful than German diesels and more flammable. But the Sherman had qualities that German tanks lacked. The wide tracks gave excellent mobility in mud and sand. The suspension was reliable and easy to repair. The interior was spacious, allowing the crew to work efficiently. The radio equipment was superior to anything Germany produced, allowing coordination that Panzer units envied. The turret traverse was powered, allowing the gunner to track moving targets while German crews cranked their turrets manually. Most importantly, the Sherman was designed for mass production. Every component was standardized. Parts from one factory fit tanks from another. The manufacturing process used techniques from automobile production, an industry America dominated globally. The Sherman wasn't a handcrafted weapon. It was an industrial product, built like a car, and produced in car factories converted for war production. In February 1942, the first production Sherman rolled off the assembly line at the Lima Locomotive Works in Ohio. By April, Chrysler's Detroit tank arsenal was producing Shermans. By June, the Pressed Steel Car Company in Pennsylvania, Pacific Car and Foundry Company in Washington, Baldwin Locomotive Works in Pennsylvania, and the Fisher Tank Division of General Motors in Michigan were all producing Shermans. The production numbers climbed with shocking speed. 1,000 Shermans in 1942, 10,000 in 1943, 17,000 in 1944. By war's end, 49 Urals 234 Sherman tanks had been produced, more than all German tank production combined for the entire war. The Germans, monitoring American production through intelligence reports, initially refused to believe the numbers. No nation could build tanks that fast. The reports must be exaggerated. Propaganda meant to intimidate. Even when evidence accumulated, German High Command dismissed American armour as quantity over quality, a desperate attempt to compensate for inferior engineering. Major General der Panzertruppe Friedrich von Mellenthin, serving in North Africa under Rommel, wrote in his diary after early encounters with Shermans in late 1942, "The American tank is mechanically reliable, but tactically inferior. Our gunners destroy them at ranges where they cannot effectively return fire. The crew show poor training. They bunch together, offering multiple targets. They retreat when pressed. With proper tactics, 10 of these machines pose no more threat than 3 Panthers." Von Mellenthin's confidence was shared throughout the Wehrmacht. German tank crews had spent years perfecting their craft. Their guns were superior. Their optics were better. Their tactical doctrine, developed through years of combat, was more sophisticated. American tanks might outnumber German armour, but numbers alone couldn't win tank battles. The Battle of Kasserine Pass in February 1943 seemed to confirm German superiority. American forces, new to combat, were badly mauled by German armour. Shermans were destroyed by the dozens. Inexperienced American crews abandoned tanks after minor damage. The defeat sent shockwaves through the US Army and provided propaganda victories for Germany. But German officers analysing Kasserine noticed something troubling. The Americans had lost approximately 200 tanks in the battle. Within 2 weeks, all losses had been replaced with new tanks from depots in Algeria. American units that should have been shattered by their losses were back at full strength before German units could exploit their victory. Oberst Rudolf Lang, commanding a panzer battalion at Kasserine, noted in his after-action report, "The Americans fight poorly, but their logistics are extraordinary. We destroy their tanks, they bring more. We damage their supply lines, they build new ones. We captured supply dumps containing spare parts, ammunition and fuel in quantities we haven't seen since 1940. One Sherman we destroyed had been hit 3 times previously and repaired each time. The repair quality was excellent using factory-made replacement parts. Our own repairs used salvaged components and field improvisation." This was the crucial difference that German intelligence failed to fully appreciate. American armour wasn't just plentiful, it was supported by a logistics system that could keep tanks running indefinitely. Every Sherman came with complete technical manuals. Spare parts were standardized across all variants. Replacement engines could be swapped in hours using specialized equipment. Ammunition was plentiful, allowing American crews to train with live fire, something German crews rarely experienced. The American logistics approach was revolutionary. Instead of repairing damaged tanks in place, severely damaged Shermans were replaced entirely with new tanks from theatre reserves. The damaged tanks were sent to depot-level maintenance facilities, where specialist crews repaired them using factory parts. This kept frontline units at full strength, while creating a sustainable repair cycle. By mid-1943, the Sherman's weaknesses were becoming apparent in combat. The 75mm gun couldn't penetrate the frontal armour of German Tigers and Panthers at normal combat ranges. The Sherman's armour was vulnerable to German 75mm and 88mm guns at ranges where American crews couldn't effectively return fire. The gasoline engine could catch fire when penetrated, earning the Sherman the grim nickname Ronson, after the lighter company's slogan, "Lights first time, every time." American tankers began calling it the Tommy Cooker and the Burning Grave. Crew casualties in penetrated Shermans were horrific. German tank crews learned to target Shermans first in mixed formations, knowing they were easier kills than British or Canadian tanks. The American response to these technical deficiencies revealed the true strength of their approach. Instead of stopping production to redesign the Sherman, multiple improvement programs ran simultaneously. Some focused on armour, some on firepower, some on survivability. The solutions were tested rapidly and implemented as running changes on production lines. In August 1943, Shermans began receiving wet ammunition storage, where ammunition was stored in water-jacketed containers. This single change reduced catastrophic fires by 60%. By January 1944, nearly all new Shermans had wet storage. In February 1944, the M4A3E8 variant entered production with horizontal volute spring suspension, providing better ride quality and allowing the installation of wider tracks. This Easy 8 model had significantly improved cross-country mobility. Most critically, variants of the Sherman were armed with different guns to address firepower problems. The 76mm gun, introduced in mid-1944, could penetrate Tiger and Panther armour at reasonable ranges. The British mounted their excellent 17-pounder gun on Shermans, creating the Sherman Firefly with firepower equal to German heavies. But the real solution to German armour superiority wasn't better American tanks, it was more American tanks. The doctrine that emerged from combat experience was simple and brutal. American tank units wouldn't duel with German heavies on equal terms, they would swarm them. The tactics were refined through bloody experience in France after D-Day. When a Sherman platoon encountered a German heavy tank, they didn't retreat. They attacked from multiple directions simultaneously. The German tank might destroy 2 or 3 Shermans, but while it engaged those targets, other Shermans manoeuvred to flanks and rear, where armour was thinner. First Lieutenant Belton Cooper, an ordnance officer with the 3rd Armoured Division, described the reality in brutal terms. It took 5 Shermans to destroy 1 Panther. The way it worked was like this. There'd be a Panther and we'd send 5 Shermans after it. The first Sherman would get hit. The second Sherman would get hit. Maybe the third. But by that time, the other Shermans had flanked the Panther and were shooting it from the side where the armour was weaker. We'd lose 3 tanks to kill 1. But we had 3 more tanks waiting to replace the losses. The Germans couldn't replace their Panther. This exchange ratio horrified American tankers but impressed German commanders with its cold mathematical logic. The Americans had solved the quality problem through quantity backed by tactical flexibility. They accepted losses that would cripple German units because American losses were always replaced within days. Staff Sergeant Lafayette Poole of the 3rd Armoured Division exemplified the evolution of American armour tactics. In his Sherman named In the Mood, Poole destroyed 258 German vehicles, including 12 tanks, from June to September 1944. His technique was constant movement, using the Sherman's reliable engine and good suspension to stay mobile, firing on the move, then immediately repositioning before return fire could be effective. Poole's after-action reports emphasized crew coordination and mechanical reliability. The Sherman isn't the best tank in the war, but it's good enough. The gun will kill anything if you hit it right. The armour will stop most hits if you angle it right. But what matters is that the damn thing always starts, always runs. We've put 2,000 miles on this tank in 3 months. It's been hit 7 times. Each time we patch it up or get parts from supply, the maintenance crews are miracle workers. Meanwhile, we see German tanks abandoned because they broke down and they don't have parts or the time to fix them. The maintenance and logistics advantage became more significant as the war progressed. By late 1944, German panzer divisions were often at 30% strength or less, not primarily from combat losses, but from mechanical failures and lack of spare parts. American armoured divisions maintained 80 to 90% operational readiness through constant supply of parts, engines, and complete replacement tanks. The Battle of Aracourt in September 1944 demonstrated how American tactics and logistics negated German technical superiority. The 4th Armoured Division faced elements of the 5th Panzer Army, including new Panther tanks. The Germans had superior tanks, better trained crews, and local numerical superiority. The Americans had something more valuable: complete knowledge of German positions through ultra-intelligence intercepts, unlimited artillery support, close air support from P-47 Thunderbolts, and immediate replacement of any losses. Over 2 weeks of fighting, the 4th Armoured Division destroyed 281 German tanks and 294 other armoured vehicles while losing 48 Shermans. Most importantly, within 3 days, all 48 losses were replaced. The German panzer units, having lost nearly half their strength, required weeks to receive replacement vehicles and never fully recovered. Colonel Bruce Clark, commanding Combat Command A of the 4th Armoured, explained the victory in his after-action report. "We didn't fight fair. When we found German tanks, we called in artillery. We called in airstrikes. We flanked them with fast-moving task forces. We used our Shermans as mobile gun platforms, not as tanks dueling other tanks. And when we took losses, battalion called and said replacements would arrive tomorrow. The Germans couldn't do any of that. They had better tanks, but we had everything else." The German response to overwhelming American armour was increasingly desperate. Tank hunting teams with Panzerfaust rockets, ambush tactics using concealed anti-tank guns, defensive positions where superior German guns could engage at long range. All of these worked tactically, but failed strategically because American tanks kept coming. By December 1944, during the Battle of the Bulge, the last major German offensive, the contrast was stark. German forces assembled 400 tanks and assault guns for the attack, a massive concentration achieved by stripping other fronts. The Americans had 600 tanks immediately available in the Ardennes, with another 1,000 in theatre reserves, and unlimited replacements available from depots in England and America. The Bulge demonstrated both German tactical excellence and strategic hopelessness. German armour achieved surprise and initial success, destroying hundreds of American tanks in the first week. But American reinforcements arrived faster than German units could exploit their gains. Within 10 days, American armoured strength in the Ardennes exceeded their strength before the attack began, despite heavy losses. Brigadier General Anthony McAuliffe, acting commander of the 101st Airborne Division, surrounded at Bastogne, famously replied "nuts" to German surrender demands. His confidence wasn't just courage. He knew the 4th Armoured Division was racing to relieve them, and that division had more tanks than the entire German force in the sector. The relief of Bastogne on December the 26th demonstrated American logistics supremacy. The 4th Armoured Division had fought continuously since June, covering hundreds of miles, engaging in dozens of battles. They had received 3 complete sets of replacement tanks, hundreds of replacement vehicles, and thousands of replacement parts. The division approaching Bastogne was at 85% strength, better equipped than when they landed in France. The German units facing them were exhausted, low on fuel, and unable to replace losses. Not because German industry couldn't produce tanks. Germany produced 27 300 tanks and assault guns during the war. But because German logistics couldn't get those tanks to the front, keep them supplied with fuel and ammunition, or provide the parts needed to keep them running. General Lieutenant Fritz Bayerlein, commanding Panzer Lehr Division during the Bulge, was captured by American forces in March 1945. His interrogation provided crucial insights into German perspectives on American armour. The Sherman is an adequate tank, but not exceptional. In a duel between equal crews, a Panther or Tiger will win. But you never fight duels. You coordinate armour, infantry, artillery and aircraft into an overwhelming attack. You replace losses immediately. You maintain your equipment properly. You always have fuel and ammunition. These advantages are more important than better tanks, Bayerlein continued. revealing German frustration. By 1945, we rarely saw individual American tanks. We saw tank infantry teams supported by artillery and aircraft. If we destroyed tanks, you brought more. If we held a position, you went around it. If we concentrated our armor, your aircraft destroyed it. The Sherman wasn't the weapon that defeated us. The American system of warfare defeated us. The Sherman was just the most visible part of that system. The production statistics told the story of inevitable defeat. At peak production in 1944, American factories completed 800 Sherman tanks per month. Germany's peak production, achieved in 1944, was 800 Panther tanks per month. The United States was building tanks at twice Germany's rate, while simultaneously producing thousands of tank destroyers, self-propelled guns, armoured cars, and half-tracks. The human cost was equally lopsided. American tank crews had an 18% casualty rate in Europe, among the highest of any branch. But those casualties were constantly replaced by trained crews, arriving from stateside training centres. German tank crews faced a 70% casualty rate by late 1944, and replacements were often poorly trained teenagers with minimal experience. The replacement training revealed the depth of American advantages. American tank training took 17 weeks. Crews learned on actual Sherman tanks, firing thousands of rounds of ammunition in practice. They studied German tactics using captured equipment. They trained as complete crews, developing coordination before combat. German tank training by 1944 had been reduced to 6 weeks, with minimal live-fire practice due to fuel and ammunition shortages. Crews often arrived at the front having never fired their tank's main gun. Some drivers had fewer than 10 hours of driving experience. The technical superiority of German tanks was negated by crew inexperience. The ammunition difference was equally stark. Each Sherman carried 97 rounds of 75mm ammunition, or 71 rounds of 76mm ammunition. American supply procedures ensured unlimited resupply. Combat reports show Sherman crews firing 40 to 50 rounds per day in heavy fighting, with ammunition trucks bringing fresh supplies each evening. German tanks carried similar ammunition loads, but resupply was uncertain. Panther and Tiger crews learned to conserve ammunition, firing only when hits were certain. This defensive mindset put them at a tactical disadvantage against American crews who could fire freely. The fuel situation was even more critical. Each Sherman required about 150 gallons of gasoline for 100 miles of travel. In heavy combat, a battalion of 50 Shermans might consume 2,000 gallons daily. American logistics provided fuel without interruption, trucked forward from supply depots fed by tankers delivering millions of gallons monthly. German tanks were more fuel efficient, but fuel supply was catastrophic. By late 1944, Panzer units frequently sat immobile waiting for fuel deliveries that never came. Dozens of Panthers and Tigers were abandoned in the Ardennes, not from combat damage but from empty fuel tanks. The Allies found German tank formations that had never engaged because they lacked fuel to reach the battle. Perhaps most frustrating for German commanders was watching American wastefulness. Damaged tanks were often abandoned rather than repaired if new tanks were available. Tanks with minor mechanical problems were sometimes replaced entirely, rather than fixed in the field. American units stockpiled spare parts in quantities that seemed insane to Germans scrounging for basic components. This apparent waste was actually brilliant logistics. Why spend 6 hours repairing a damaged tank when a replacement could arrive in 2 hours? Why risk a breakdown during an attack when a fresh tank guaranteed reliability? The Americans could afford to be wasteful because their production capacity was unlimited. The industrial mobilization that enabled this avalanche of armor was unprecedented. The Chrysler Detroit tank arsenal, built from farmland in 1940, covered 113 acres under roof and employed 40,000 workers. At peak production, the facility completed 1 Sherman every hour, 24 hours daily. The assembly line was 3/4 of a mile long. The workforce was revolutionary. Women comprised 25% of tank production workers. Many had never worked in manufacturing before Pearl Harbor, yet they welded armor plate, assembled engines, and performed precision work to tolerances measured in thousandths of an inch. The quality control was rigorous. Each tank was test-driven before acceptance. Engines were run-tested for 24 hours. Guns were bore-sighted and test-fired. The production process used techniques from automobile manufacturing scaled up to military requirements. Components were manufactured by subcontractors and delivered to assembly plants. Engines came from multiple suppliers, transmissions from others, armor plate from steel mills. The final assembly integrated these components into completed tanks. This distributed production meant bombing couldn't stop the flow. Germany concentrated tank production in a few large facilities. Allied bombing raids could severely impact production. American tank production was distributed across dozens of facilities in multiple states. No single attack could significantly reduce output. The variants demonstrated American flexibility. The basic Sherman chassis was adapted for dozens of specialized roles: M4A3 with HVSS suspension, M4A1 with cast hull, M4A2 with diesel engine for Marine Corps use, M4A4 with elongated hull for British use. Each variant used the same basic components, ensuring parts interchangeability. Specialized variants included the M4 dozer tank with bulldozer blade, the M4 flail tank for mine clearing, the M4A3 E2 jumbo with extra armor, the Sherman Crab with chain flails, the Sherman duplex drive, an amphibious variant for D-Day, the M32 tank recovery vehicle for salvaging damaged tanks, the M7 Priest self-propelled howitzer using the Sherman chassis. This adaptability meant the Sherman wasn't just a tank. It was a platform that could be rapidly modified for any armoured role. German tanks were highly specialised, each designed for specific purposes. American armour was flexible, adaptable to changing requirements without retooling entire factories. The Lend-Lease program extended American armour production globally. The Soviet Union received 1,402 Sherman tanks, along with thousands of other vehicles. British and Commonwealth forces received 17,081 Shermans. Free French forces were equipped entirely with American armour. Even China received a small number of Shermans for their operations in Burma. The global reach of American production demoralised German intelligence analysts. They were fighting not just American armour but British armour supplied by America. Soviet armour supplemented by American tanks. French armour entirely American. Polish, Canadian, New Zealand, South African, Brazilian forces, all equipped with American vehicles. The Wehrmacht faced American industrial output on every front simultaneously. Soviet General Georgy Zhukov, when asked after the war about factors in defeating Germany, emphasized logistics. The Americans supplied us with material without which we could not have formed reserves or continued the war. We didn't have explosives, gunpowder. We didn't have the capacity to produce the quantity of artillery shells and tanks we needed. The Lend-Lease tanks were not as good as our T-34, but they arrived when we desperately needed them. More importantly, the trucks, the jeeps, the food, the radios, all American. This support was crucial. The Sherman's mediocrity in tank versus tank combat was compensated by its excellence in combined arms operations. The tank was designed to support infantry, not to duel other tanks. The high profile that made it vulnerable also provided excellent visibility for the crew. The powered turret allowed rapid engagement of multiple targets. The reliable radio enabled coordination with infantry, artillery, and aircraft. American doctrine emphasized the combined arms team. Infantry cleared anti-tank weapons, allowing tanks to advance. Tanks suppressed enemy positions, allowing infantry to maneuver. Artillery provided preparatory fires. Aircraft struck targets beyond artillery range. Combat engineers removed obstacles. The entire system worked together with the Sherman as one component. German doctrine, by contrast, emphasized tank-centric operations. Panzer formations were expected to achieve breakthroughs independently. Infantry and artillery supported the tanks rather than operating as equals. This worked early in the war when German armour was superior and Allied air power weak. By 1944, it was suicidal. The introduction of the M26 Pershing heavy tank in February 1945 demonstrated that America could build tanks equal to German heavies. The Pershing had a 90mm gun that could penetrate any German armour. It had thick frontal armour resistant to German 88mm guns. Its performance matched the Panther. Only 20 Pershings reached Europe before war's end, not because America couldn't produce more, but because they weren't needed. The Sherman was good enough. The war was being won with existing equipment. Why delay victory retooling factories for a marginally better tank? This pragmatism infuriated American tankers, who wanted better equipment but revealed the strategic thinking that defeated Germany. The Americans didn't need the best tank. They needed enough good tanks, properly supported with trained crews, backed by overwhelming logistics. In April 1945, as Allied armies crossed the Rhine and drove into Germany, the contrast between American and German armour forces was absolute. American armoured divisions operated at near full strength, over 200 tanks per division. They advanced 30 to 40 miles daily, supplied by truck convoys bringing fuel, ammunition, food, and spare parts. Combat losses were replaced within hours from theatre stocks. German panzer divisions existed mostly on paper. Most had fewer than 20 operational tanks. They moved at night to avoid air attack. Fuel was so scarce that tanks were often towed into position by half-tracks to conserve fuel. Ammunition was rationed. Spare parts didn't exist. Crews abandoned tanks for minor mechanical failures because repair was impossible. General Oberst Heinz Guderian, Inspector General of Panzer Troops, wrote in his memoirs about the final months. "We had excellent tanks. The Panther was magnificent. The Tiger was formidable. The King Tiger was the best tank in the world. None of it mattered. We couldn't fuel them. We couldn't supply them with ammunition. We couldn't replace losses. We couldn't train crews." Meanwhile, the Americans brought mediocre tanks in unlimited quantities supported by excellent logistics. In war, adequate equipment that actually reaches the battlefield wins over excellent equipment that doesn't. The final statistics of Sherman production revealed the scale of American industrial mobilization. 49,234 Sherman tanks produced. 95% production efficiency rate. Less than 2% rejected during quality control. Average production time from raw materials to completed tank, 10 days. The fastest Sherman was built in 8 hours as a publicity demonstration in Detroit, though that tank wasn't combat-worthy. The supporting production was equally impressive. 684,000 Jeeps produced, 2.4 million trucks produced, 41 billion rounds of ammunition produced, 6,500 naval vessels produced, 300,000 aircraft produced, 2.3 million tons of armor plate produced. The American industrial machine mobilized for total war built more of everything than all other nations combined. The human dimension of this production deserves recognition. 18 million Americans served in the military. 16 million more worked in war industries. The transition from peace to war production took 18 months. Factories producing consumer goods retooled to produce weapons. Workers moved from civilian jobs to war work. Women entered the workforce in unprecedented numbers. The American economy nearly doubled in size between 1940 and 1945. This mobilization required government coordination, private industry cooperation, labor union participation, and public support. It required rationing of consumer goods, price controls, allocation of raw materials, and prioritization of military production. The American people accepted these sacrifices because they understood the stakes. The Sherman tank, perhaps more than any other weapon, symbolized this mobilization. It wasn't the best tank. German tanks had better guns, better armor, better engineering. But the Sherman was good enough, and there were 50,000 of them, backed by millions of trained soldiers, unlimited supplies, and an industrial base that could replace every loss and build more besides. When German officers stood in the rubble of their defeated nation in May 1945, they finally understood what they had faced. Not just better tactics or superior soldiers, but an industrial colossus that had buried them under an avalanche of material. They had brought expertise to a production contest. They had brought quality to a quantity fight. They had brought limited resources to face unlimited industrial capacity. The Sherman tank didn't win World War II. But 50,000 Shermans arriving in an endless stream, supported by perfect logistics, crewed by trained soldiers, backed by unlimited ammunition and fuel, working within a combined arms system that integrated all military capabilities, proved unstoppable. German officers had laughed at American industrial threats. They stopped laughing when the 50,000th Sherman rolled off the assembly line, and they realized America had just kept building. The factories that won the war continued operating. The workers who built Sherman tanks went on to build the machines that rebuilt Europe and Japan. The industrial capacity that defeated fascism became the foundation of American global power for the next half-century. The Sherman tank, dismissed by experts and feared by its own crews, became a monument to a simple truth. In total war, the nation that can build 50,000 adequate tanks will always defeat the nation that builds 5,000 excellent tanks. The Germans learned this lesson in burning wreckage across 2 continents. The factories of Detroit, Cleveland, and Los Angeles had spoken, and their voice was thunder made of steel. The mathematical inevitability of German defeat became apparent to Wehrmacht analysts by mid-1944, though the High Command refused to acknowledge it publicly. A classified report prepared by the Heereswaffenamt, the German Army Weapons Agency, in July 1944 laid out the numbers with brutal clarity. American tank production for 1944 was projected at 17,000 units. German production, even after Albert Speer's rationalization efforts, would reach perhaps 9,000 tanks and assault guns combined. But the real disparity wasn't in production, it was in what happened after production. Of 9,000 German tanks produced, perhaps 6,000 would reach combat units. The rest would be destroyed in transit by Allied bombing, suffer mechanical failure during delivery, or sit in depots awaiting spare parts that never arrived. Of the 6,000 reaching combat units, half would be non-operational within a month due to lack of maintenance capacity at the front. American tanks told a different story. Of 17,000 produced, nearly 16,000 reached combat theatres. The Atlantic crossing was safe, protected by overwhelming naval superiority. Depots in England, North Africa, and later France maintained thousands in ready reserve. American maintenance doctrine kept 85% operational at any given time. The effective combat strength disparity wasn't 17,000 versus 9,000. It was more like 13,000 versus 3,000. The report included a fascinating section on crew training ratios. America was training 5,000 tank crews monthly by mid-1944. Germany was training perhaps 800, and those with minimal preparation. The Americans were building not just more tanks, but more complete tank systems, trained crews, supply chains, maintenance capacity, the entire ecosystem needed for sustained armoured warfare. Oberst Dr. Hans von Luck, a Panzer Regiment commander serving in France before D-Day, recalled reading excerpts from this report. "I remember thinking, this cannot be accurate. No nation can build so many tanks, train so many crews, supply so many vehicles. It must be propaganda meant to demoralize us." Then came June 6th. Then came the breakout from Normandy. Then I understood. Every number in that report was conservative. The reality was worse than our analysts predicted. Von Luck's 21st Panzer Division faced the Allied invasion with 127 operational tanks on June 6th, a respectable number for a German armoured division in 1944. By June 30th, after less than a month of combat, the division had 17 operational tanks. Losses had been heavy but not catastrophic, perhaps 60 tanks destroyed in combat. The other 50 had broken down, run out of fuel, been abandoned for lack of spare parts, or were awaiting maintenance that repair units couldn't provide. During that same month, the division had received exactly 14 replacement tanks. Not enough to replace combat losses, much less mechanical failures. Meanwhile, von Luck watched American armoured divisions lose similar numbers in combat and return to full strength within days. It was like fighting the ocean. You would push back one wave and another would arrive. You would destroy a company of Shermans and the next day they had more Shermans than before you attacked. The psychological impact on German tank crews was devastating. Veteran Panzer soldiers who had survived Russia, North Africa and Italy found themselves fighting defensively against an enemy they had once considered inferior. The tactical situation had reversed completely. Where German tanks had once conducted offensive sweeps, they now fought from ambush positions, trying to destroy American tanks before being overwhelmed by numbers. Oberfeldwebel Otto Carius, one of Germany's most successful tank aces with 150 confirmed kills, described the changing nature of tank combat in his post-war memoir. "In Russia, we hunted Soviet tanks. We had better optics, better training, better tactics. We could destroy 3 or 4 T-34s before they effectively returned fire. Against the Americans, we had the same advantages: better optics, better training, better tactics. It didn't matter. We would destroy 3 Shermans and 5 more would appear. We would destroy those 5 and 10 more would arrive. You couldn't win by being better. You could only delay losing." Carius fought in a Tiger tank, the most feared German armour of the war. The Tiger's 88mm gun could destroy a Sherman at 2,000 metres, far beyond the range where the Sherman's gun was effective. The Tiger's frontal armour was impervious to the Sherman's 75mm gun at any range. In a fair fight, the Tiger won every time, but American tactics ensured there were no fair fights. When Tigers appeared, American units called for artillery. They called for airstrikes. They brought up tank destroyers with 90mm guns. They attacked from multiple directions simultaneously, forcing the Tiger to expose thinner side armour, and always, they brought more Shermans than the Tiger had ammunition to destroy. Carius recounted an engagement near Malinava in Lithuania in July 1944. His platoon of 3 Tigers encountered an American armoured column with at least 40 Shermans. The tactical situation was perfect for the Tigers: hull-down positions on high ground, clear fields of fire, retreat routes prepared. The engagement lasted 20 minutes. The Tigers destroyed 17 Shermans without taking a hit. Then the Americans called artillery. Then American fighter bombers arrived. The Tigers withdrew, having won the tactical engagement but accomplished nothing strategic. The American column, reduced by 17 tanks, continued advancing with 23 Shermans remaining, and by evening had received 20 replacement tanks from reserve stocks. "We couldn't win," Carius admitted. "We could kill them, but we couldn't stop them. They could absorb losses that would destroy our entire army and barely notice. One American armoured division had more tanks than our entire Western Front, and they had dozens of armoured divisions." The disparity in combat support was equally significant. Every American tank battalion had an attached maintenance company with specialised recovery vehicles, spare parts and trained mechanics. The M32 tank recovery vehicle, built on the Sherman chassis, could tow disabled tanks to repair facilities, extract tanks from mud or obstacles, and perform field repairs. American doctrine emphasised recovering damaged tanks. Anything that could be salvaged was salvaged, repaired, and returned to service. German recovery capabilities had collapsed by 1944. The Wehrmacht had some excellent recovery vehicles, but far too few. Damaged tanks were often abandoned because recovery wasn't possible. Tanks with repairable damage were destroyed by their crews to prevent capture. The Panther and Tiger tanks, magnificent machines when operational, became scattered wrecks across France because Germany couldn't recover and repair them. Maintenance philosophy revealed deeper differences. The Sherman was designed for maintenance. The engine could be removed and replaced in 2 hours using proper equipment. Track replacement took 4 hours. The transmission was accessible for field repair. Technical manuals covered every component. American mechanics were trained on actual equipment, learning hands-on repair skills. German tanks were engineering marvels but maintenance nightmares. Panther engines required 30 hours to remove and replace. Track pins were difficult to access. Transmissions were buried deep in the hull. Technical manuals were often unavailable at unit level. German mechanics learned through experience, not systematic training, meaning maintenance quality varied wildly. The Tiger tank exemplified this problem. It was the most powerful tank of its era, feared by every Allied soldier. It was also a maintenance disaster. The overlapping road wheel system collected mud and froze in winter. The 700 horsepower engine was temperamental and required constant adjustment. The transmission was fragile and failed frequently. The fuel consumption was catastrophic, 1.5 gallons per mile. A Tiger tank required 10 hours of maintenance for every hour of operation. American intelligence officers interrogating captured Tiger crews found maintenance consumed more time than combat. Crews described spending entire days performing preventive maintenance, adjusting track tension, checking engine timing, lubricating components. One crew reported their Tiger had been operational for only 60 hours over 2 months, not from combat damage but from recurring mechanical problems. The Sherman, by contrast, required perhaps 2 hours of daily maintenance and could operate continuously for weeks. The radial engine was reliable and forgiving of maintenance lapses. The suspension required minimal attention. Crews could perform most maintenance tasks without specialized tools. This reliability multiplied American numerical advantages. Not only did America have more tanks, but those tanks were available for combat at higher rates. The fuel situation became critical in the last year of the war. Each Sherman battalion consumed approximately 10,000 gallons of gasoline daily in active operations. The American logistics system delivered this fuel without interruption through a pipeline system that eventually stretched from ports in France to the German border. The Red Ball Express, a convoy system of 6,000 trucks, moved 12,500 tons of supplies daily at the height of operations. German forces watched this logistics miracle with envious despair. General Major F.W. von Mellenthin, Chief of Staff for several panzer armies, wrote extensively about the American logistics advantage. The Americans built their armies like they built their automobiles, as systems requiring constant supply of fuel and parts. Their supply system delivered this support with machine-like efficiency. A German panzer division required 50 tons of supplies daily to remain operational. An American armoured division required 300 tons daily. The Americans delivered 300 tons daily. We rarely received even 50 tons. The consequence was German tanks sitting immobile for lack of fuel, while American tanks operated continuously. During the pursuit across France in August 1944, German forces abandoned hundreds of armoured vehicles due to empty fuel tanks. The 116th Panzer Division left 90 tanks between Paris and the German border, only 20 destroyed by combat, the rest abandoned for lack of fuel. American forces, advancing too fast for their supply lines, experienced their own fuel shortage in early September 1944. The advance halted for 2 weeks while logistics caught up. German commanders hoped this pause meant American logistics had collapsed. Instead, within 14 days, Allied supply dumps in France held sufficient fuel for operations through the winter. The Americans hadn't stopped because they couldn't supply their forces. They had stopped to build up supplies to overwhelming levels before continuing. This abundance showed in combat operations. American tank commanders could call for massive artillery support without worrying about shell expenditure. American pilots flew multiple sorties daily because aviation fuel was unlimited. American infantry advanced knowing resupply would arrive on schedule. German forces rationed everything: shells, fuel, even small arms ammunition. The winter of 1944-1945 showed the culmination of these logistics advantages. The Battle of the Bulge, Germany's last major offensive, was designed partially around captured American fuel supplies. German planners knew their forces couldn't carry enough fuel for the operation and counted on capturing American dumps. The offensive achieved surprise and initial success but stalled partially because German forces couldn't capture fuel supplies intact. American demolition teams destroyed fuel dumps before German forces arrived. Meanwhile, American response to the German attack demonstrated logistics superiority. Within 48 hours, the 101st Airborne Division was rushed to Bastogne with full ammunition, despite having no organic transportation. Trucks were diverted from supply runs to move troops. Within a week, entire armoured divisions with thousands of vehicles had been moved hundreds of miles and were counter-attacking. The speed and scale of this redeployment exceeded anything German forces could have accomplished, even in 1940 at the height of their power. The industrial statistics behind this logistics achievement were staggering. America produced 2.4 million military trucks during the war, enough to motorize entire armies. Germany produced 350,000 trucks and relied heavily on horses for logistics. At war's end, the Wehrmacht still used horses for the majority of its supply transport. The American army had virtually no horses in combat theatres except for ceremonial purposes. The truck production differential meant American logistics could support forces far from ports and railheads. German logistics depended on railroads, which Allied air power systematically destroyed. By 1945, moving supplies within Germany was nearly impossible by rail. German armies starved while depots full of supplies sat inaccessible because destroyed bridges and tracks prevented transportation. American ammunition production for tank guns alone exceeded German production for all artillery weapons. Each Sherman carried approximately 900 pounds of ammunition. With 50,000 Shermans produced, approximately 45 million pounds of tank ammunition was manufactured just for initial loads, not counting resupply. This didn't include ammunition for the 50,000 other armoured vehicles produced: tank destroyers, self-propelled, guns, armoured cars, or the billions of small arms rounds. The economic analysis revealed why Germany could never match American production. The United States had gross domestic product of approximately $200 billion in 1940. Germany's was perhaps $50 billion. When America fully mobilized for war, it devoted roughly 40% of GDP to military production, approximately $80 billion annually at peak. Germany devoted perhaps 60% of its smaller GDP, approximately $30 billion annually. America was outspending Germany nearly 3-1 on military production, while maintaining a higher civilian standard of living. More significantly, American military production didn't disrupt civilian economy. Consumer goods were rationed but available. Housing construction continued. Infrastructure was maintained and improved. The American economy grew during the war. The German economy was strip-mined for war production. Civilian consumption collapsed. Infrastructure deteriorated. The economy shrank even as military production increased. This meant America could sustain war production indefinitely. Germany was consuming its economic seed corn and would collapse even without military defeat. By 1945, German civilians were starving, cities were rubble, transportation had collapsed, and industrial production was falling despite desperate efforts to increase output. The German economy was dying from the strain of total war. American economic strength showed in unexpected ways. When Sherman tanks were found vulnerable to German 88mm guns, the American response wasn't to accept losses or redesign the tank. It was to produce more Shermans faster than Germany could destroy them, while simultaneously developing better variants. Multiple approaches ran in parallel because America could afford multiple solutions. The Sherman Jumbo, heavily armoured variant with frontal armour equivalent to the Tiger, entered production in May 1944. Only 254 were built, but production ran simultaneously with standard Shermans. The 76mm gun Sherman entered production in January 1944 and by war's end represented 30% of production. The British 17-pounder armed Firefly entered service in early 1944. Each solution addressed the firepower problem differently. All were produced simultaneously. Germany couldn't afford this parallel development. Resources were too limited. When the Panther tank proved to have final drive problems, there weren't resources to develop alternatives. The problematic design remained in production because stopping to fix it would reduce output. German engineers knew the solutions but couldn't implement them because production couldn't be interrupted. This led to German tanks entering service with known defects. The Panther's final drive typically failed after 150 kilometers, about 90 miles. The problem was understood, the fix was designed, but implementing it would require retooling. So Panthers went to combat with final drives that would probably fail during the first week of operations. Crews learned to carry spare final drives and replace them in the field, accepting that their sophisticated tank had a critical component with lower reliability than a farm tractor. The Tiger II, the ultimate German tank with a 128mm gun and impervious armour, entered service in 1944 with similar problems. The transmission was inadequate for the 70-ton weight. The suspension was overstressed. The engine was underpowered. All these problems were known. None could be fixed because stopping production to redesign was unacceptable. Germany needed tanks immediately, even flawed tanks, because the alternative was no tanks at all. American engineers would have stopped production to fix such problems. The industrial capacity existed to absorb a production pause. But American tanks rarely had such fundamental flaws because the design philosophy emphasized reliability over performance. The Sherman was designed to be reliable first, capable second. The result was a tank that actually worked under field conditions, rather than a sophisticated machine that spent more time broken than operational. Crew comfort was another unexpected advantage. The Sherman had a spacious interior by tank standards. The crew could move around, swap positions, assist each other. The ergonomics were carefully considered. Controls were logically placed. Visibility was excellent. The result was a crew that could fight effectively for extended periods without exhaustion. German tanks prioritized armor and firepower over crew comfort. The interiors were cramped. The Tiger had barely enough room for its crew. The Panther was worse. Crews in German tanks became exhausted quickly from the physical demands of operating in confined spaces. The loader in a Tiger had perhaps the hardest job in any tank, manhandling 40-pound shells in a cramped turret while the tank maneuvered violently. This comfort differential affected combat effectiveness. American crews could fight for 12 hours and remain effective. German crews were exhausted after 6 hours. In sustained operations, this meant American tanks maintained effectiveness, while German performance degraded from crew fatigue. The radios were another crucial difference. Every Sherman had an SCR 528 radio for intertank communication and an SCR 506 for communication with higher command. The radios were reliable, easy to operate, and provided clear communication. American tactical doctrine emphasized radio coordination. Tank platoons worked together seamlessly, coordinating fire and movement, because they could communicate clearly. German tank radios were less reliable and fewer in number. Not every tank in a platoon had radios. Communication often relied on visual signals, limiting coordination. German tank tactics were based on experienced commanders making decisions for their units. This worked when commanders were veterans but collapsed when casualties forced promotions of inexperienced officers. The American system didn't depend on genius commanders. The radio nets allowed coordination by competent officers following doctrine. The result was consistent performance across units. German performance varied wildly depending on the quality of local commanders. Elite units with veteran commanders were formidable. Average units with replacement commanders were mediocre. By spring 1945, the quality gap had reversed completely. American armoured units were filled with veterans who had fought across France and into Germany. They knew their equipment. They knew their tactics. They had experienced every combat situation. German units were filled with teenagers drafted in desperation, led by officers promoted too fast, equipped with tanks they barely understood. The surrender in May 1945 found American armoured divisions at peak capability. The 2nd Armoured Division, first American armoured unit to enter combat in North Africa, had fought continuously for nearly 3 years. It ended the war with better equipment than it started, more experienced crews, and refined tactics tested in hundreds of battles. The division had received roughly 5 complete sets of replacement tanks during the war and had maintained near constant combat readiness. The German 2nd Panzer Division, which had spearheaded the invasion of France in 1940, surrendered in May 1945 with perhaps 20 operational tanks and a handful of survivors from the original cadre. The division had been rebuilt 3 times after destruction in Russia. Most of its equipment was abandoned for lack of fuel in the final weeks. The crews who surrendered were exhausted, demoralized, and relieved the war was over. The post-war analysis conducted by American, British, and German officers reached surprising consensus. The Sherman wasn't the best tank of World War II. The German Panther and Tiger were probably superior in direct combat, but the Sherman was good enough, and there were 50,000 of them, and they were backed by a logistics system that kept them running, crewed by trained soldiers, and supported by an industrial base that could replace any losses. General Oberst Heinz Guderian, the father of German armoured doctrine, concluded after the war, "We lost the tank war before it began, not on the battlefield but in the factories. Not to better design but to overwhelming production. We built excellent tanks in inadequate numbers. The Americans built adequate tanks in overwhelming numbers. In total war, quantity has a quality all its own. We forgot this lesson from the First World War and paid the price again." The final American tank production numbers told the story. 49,234 Sherman tanks, 8,053 M3 Lee Grant medium tanks, 28,819 light tanks of various models, 67,506 total tanks produced. Germany produced approximately 27,300 tanks and 12,000 assault guns, total 39,300 armoured fighting vehicles. The United States produced 1.7 times as many tanks, while simultaneously producing more of every other weapon system, more aircraft, more ships, more trucks, more artillery, more of everything. The economic victory was total. The military victory was inevitable. The Sherman tank, derided by critics and feared by its own crews, proved adequate for the task because America could build 50,000 of them. German officers who had laughed at American industrial threats in 1941 stood in the rubble of their nation in 1945 and understood too late that they had lost the war in the factories of Detroit and Cleveland, not on the battlefields of France and Germany. The industrial avalanche they had dismissed as impossible had buried their armies under steel, buried their economy under strategic bombing, and buried their hope under the mathematical certainty of American production. The assembly lines had spoken, and their verdict was final.